So looking at number 1, I'm going to say let u equal what? 2x plus 1, perfect. So then du would equal the derivative of that, so that would be 2 dx. So I need to make sure I put a 2 in there so I can multiply by 2. That way I have 2 dx. If I multiply by a 2, I need to also multiply by 1/2 on the outside. So now when we use substitution, I have 1/2 on the outside, and then x over the square root of u, which I'll call u to the 1/2 power, du. I can't take the antiderivative when I have an x and a u, so what would I need to do to switch that x to be a u? I'm going to take my equation that I have for u here and solve it in terms of x, or make it x equals. So I have u minus 1 equals 2x, and then when we divide by 2, we get x equals u minus 1 over 2. So this is what I'm going to be substituting into the x. So I have 1/2 times the integral of u minus 1 over 2 over u to the 1/2 power du. So now everything's in terms of u. So we need to do a little bit more simplifying before we can take our antiderivative. We could keep change flip here, so I'm going to keep the top, change to multiplication, and flip the bottom. So u to the 1/2 power is kind of like a whole number, so we'd flip it to, so multiply by 1 over u to the 1/2 power. So we get 1/2 times the integral of u minus 1 over 2 u to the 1/2 power du. You could leave it like this and then split it up into 2 different terms. I'm going to move the 2 out front. So since I'm dividing by 2, that's the same as multiplying by 1/2. And since it's a constant, I can bring it out front. So I can multiply the 1/2 out here. So if I had, let's say, the integral of 3x dx, I can just move that 3 out front instead of writing it on the inside. So that's what we're doing here. Since we're dividing by 2 or multiplying by 1/2, I just put the 1/2 on the outside. So 1/2 times 1/2 on the outside would be 1/4 times the integral of u minus 1 over u to the 1/2 power du. Still can't take the antiderivative of this, but I would want to split up my terms to simplify. So I have 1/4 times the integral of u over u to the 1/2 minus 1 over u to the 1/2 du. Any questions on what we've did so far? Okay, perfect. So 1/4 times the integral. When I'm dividing, how would I combine these terms? What do I do to the exponent? Subtract. So my exponent on top is 1 minus 1/2 would be u to the 1/2 power. Minus, when we bring the u to the top here, our exponent turns negative, so u to the negative 1/2 power du. Now we can take our antiderivative. So I'm just going to leave the 1/4 outside. Then I have u to the 3/2 power times 2/3 minus u to the 1/2 power. When I add 1 and then divide by 1/2, we get times 2. Now this is a definite integral, but the reason why I haven't put the numbers on my integral for each step is because I changed it to be in terms of u. We could either change it back to be in terms of x, we can substitute our x's back in, or I could make these x values that I have here, I can make them u values. You could do it either way. If you plug in these numbers, you need to make sure that they go into the x's. These are x values. I'm going to change them to be u values, so I can just plug it into my u's. That way I don't have to plug the x's back in and then plug in my x values. So if we change these to be u values, I have x equals 0. So then u would equal, we plug in x, 0 into the x here. So 0 times 2 plus 1 would be 1. We have x equals 4. So again, I plug in 4 into my x here. And we get u equals what? 9. So these are my u values that I'm going to use here. That way I don't have to plug back in the x's. So my integral is from 1 to 9. So now that I have u values, I can substitute these into my u's or plug these into my u's. So I have 1/4. I'm just going to leave that 1/4 outside. Actually, I could distribute it. Either way, it doesn't matter. I'm going to distribute it just to make our fractions a little bit nicer. So I'm going to distribute it here. So this would be 1/6 u to the 3/2 power, bless you, minus 1/2 u to the 1/2 power from 1 to 9. Now I'm going to plug 9 in. So we have 1/6 times 9 to the 3/2 power minus 1/2 times 9 to the 1/2 power minus, then we're going to plug in 1. So we have 1/6 times 1 to the 3/2 power minus 1/2 times 1 to the 1/2 power. Then from here we just have to do the math. So 9 to the 3/2 power is like saying the square root of 9 cubed. So the square root of 9 is 3, and 3 cubed would be 27. So I have 27 over 6. This simplifies, we can simplify it now. Let's divide them both by 3. We get 9 over 2. 9 to the 1/2 power, yes. Okay, so this would be the square root of 9, which would be 3, so minus 3 over 2. So then 9 minus 3 would be 6 over 2, which would give us 3. Let's do the same thing here. 1 to the 3/2 power would just be 1, so this is 1/6 minus 1/2. I need a common denominator, so I can multiply the top and the bottom by 3 here, so we get 3 over 6. So 1 minus 3 would be negative 2 over 6, which would simplify to negative 1/3. So we have minus negative 1/3, which would turn into a plus. Then we need a common denominator again. This would change to 9 over 3. So 9 plus 1 would be 10 over 3. All right, let's look at number 6. So here we have an indefinite integral. We don't have numbers on our integral, so we just need to take our antiderivative and make sure we plug back in the x's into our u's. So I'm going to say, let u equal what? 4x squared plus 3. So then du would be the derivative of this. What's our derivative of 4x squared plus 3? 8x dx. Perfect. So I'm going to substitute my u into the 4x squared plus 3. And then I have a x dx, but what am I missing? I'm missing 8. So I'm going to put an 8 in here. But then what else do I have to do? Multiply by 1/8 on the outside. We got to keep this balanced. So now I'm going to substitute in. I've got 1/8 times my integral of 8x dx is going to change to du, so that we just have u cubed du. So 1/8 times, we can take our antiderivative from here, u cubed. The antiderivative would be u to the 4th power times 1/4. What am I missing here for my indefinite integral? plus c, perfect. Now we're going to distribute the 1/8. It doesn't really get distributed to the c because c is just a constant. So we've got 1 over 32 u to the 4th power plus c. What else do I have to do? Could I leave my answer like this? No. We have to plug back in our x's. So we got to plug 4x squared plus 3 back into u. So I have 4x squared plus 3 to the 4th power. You could either say times 1 over 32 or just over 32. Either way works. Yes. When we took the antiderivative. So that would be our answer. So on the third page, number 6. When I'm taking the antiderivative here, when I'm doing the integral, what would I want to do first? Would I use substitution here? So for this one, you could try using substitution, but it's almost just going to make it more complicated. We can distribute our x to the 1/2 power inside of our parentheses. So we have our integral from 0 to 1. How else could I call x the square root of x? What else would I write this as? X to the 1/2 power, perfect, times 1 minus x dx. When I distribute this, I'll get x to the 1/2 power. What is x to the 1/2 power times x? Awesome, x to the 3/2 power. Our exponent on this x would be a 1, and we add the exponents. We get x to the 3/2 power from 0 to 1. Now we can take our antiderivative. So we have x to the 3/2 power times what? Times 2 over 3, perfect, minus x to the 5/2 power times 2 over 5. And this is from 0 to 1. What would I plug in first? Awesome, plug in 1. So we have 2/3 times 1 to the 3/2 power minus 2/5 times 1 to the 5/2 power minus, then we're going to plug in 0. So we get 2/3 times 0 to the 3/2 power minus 2/5 times 0 to the 5/2 power. From here, we just have to be careful with the math. What's 1 to the 3/2 power? 1. So then we multiply that by 2/3. We get 2/3. 1 to the 5/2 power would be 1 times 2/5 would just be 2/5. I need a common denominator here. So I can multiply the top and the bottom by 5. So we get 10 over 15. And then 6 over 15. 10 minus 6 would be 4 over 15. Then minus, what would we get here? 0. So what would our answer be? 4 over 15. Perfect. Great job. Perfect. Let's do number 9. We want to find the average value of the function over the given interval. Find the values of x for where the function assumes its average value, and we're not going to graph it. So let's start by finding our average value. To find our average value, we're going to take our integral from 4 to 9 of 1 over square root of x. What do I have to multiply this by? Awesome. 1 over b minus a. So this is our a and our b. So 1 over 9 minus 4. So 1 over 5 times our integral of 4 from 4 to 9. Of how else could I write this? X to the power of negative 1/2. Perfect. Dx. Now when we take our antiderivative, we would get x to the 1/2 power from 4 to 9. This is times 1/5. So I would plug in 9 first. We would get 9 to the 1/2 power minus 4 to the 1/2 power. So 3 minus 2 would be 1. Times 1/5 would be 1/5. So 1/5 is our average value. If the question just asked for average value, this would be our answer. Yes? You're right, I forgot that. This should be 2, yeah. So it would be 2 times 3 and 2 times 2. She left.
Oh, I was like trying to be on my thing.
Thank you. 6 minus 4. She was observing us. All right, so we get 2/5. 2/5 is our average value. So if the question just asked for average value, that's all we would do. We would find our integral, multiply that times 1/b minus a. If it asks for our values of x, which is just our values of c, is what we would call it, same thing. What would we need to do to find our values of c? We would set our, yes, perfect. I didn't think you guys would answer. So we would set our average value equal to the question, our function here, 1/√x. Then from here we could cross multiply to solve. So 2 square root x is equal to 5, divide by 2. Square root of x is equal to 5/2. What would I do next? Square both sides, perfect. So we get x equals, we square the 5 and square the 2, so 25/4. So this would be our value of x, or our value of c. Awesome, let's look at 11a. So 11a, we want to find our integral from 3 to 4. So I've got this funky shape here. Not quite a triangle, not quite a rectangle. What would I do to find my area here? You could, that would work. If you wanted to find the area of the whole triangle here and then subtract this, you could totally do that. I would probably cut this in half and find the area of the rectangle and then just add the area of the triangle. You could do it either way, both ways work. So I'm gonna find the area of our rectangle here, which ends up being a square, because our sides are the same. So our area of this one would be 1, plus our area of the little triangle on top. Our base is 1 and our height is 1, so our area here would be 1/2. So we add these together, our area would be 3/2. Be careful if your part of the graph is below the x-axis. Remember, your area is going to be negative. Your integral will be negative. If I was then finding the area of this part of it, let's say, we would subtract this part from our answer because it's below the x-axis. So that was kind of a common mistake that people would make on the quiz. If it's below the x-axis, your area is going to be negative. So for here, we want to find our definite integral. What could we do here? Awesome. I'm going to let u equal x plus 1. So then what's du equal to? 1 dx. Perfect. So I've got the integral. I'm not going to put numbers on it because now I'm putting in the u. So these are x values. If I want to change them to u values, I could in this step. But we have our integral from, or our integral of 1 over the square root of u du. Just substitute our u and du in. So when I take my antiderivative, actually before I do that, what would we rewrite this as to make it a little bit easier for us to take our antiderivative? Awesome, u to the negative 1/2 power. Now when I take my antiderivative, I get u to the 1/2 power times 2. Now I could either substitute my x's back in at this point, or I could change my values to u values. I'm going to change my values to u values. So when x is equal to 0, we want to see what does u equal. So if I plug in 0 into my u equation up here, into the x, I would get 1. And then when x is equal to 1, what does u equal? What would u equal when x is 1? 2. Perfect. So our integral would be from 1 to 2. So we have 2 times 2 to the 1/2 power minus 2 times 1 to the 1/2 power. Bless you. So we would get 2 square root 2 minus 2. Are these like terms? Can I combine these? No. So that would be our answer. Unless the question allowed decimals, then just put it in your calculator, get a value for it.